Hi guys, welcome to our channel Swipejalan. Welcome to our latest video of part 2 of object-oriented programming. Today we are diving into two powerful concepts that will take your coding skills to the next level, that is abstraction and polymorphism. Abstraction helps you focus on the essential features while hiding complexity, as we see in our previous video about the basic pillars of OOPS. Whereas polymorphism allows objects of different types to be treated as instances. So, join us as we explore these concepts with clear explanation, real world examples, and coding demonstrations. Whether you're a beginner or looking to refresh your knowledge, this video is designed to help you master abstraction and polymorphism. Let's get started. So, as the definition states, abstraction is the process of hiding complex implementation. Like whatever the details are stored, they are in a capsule format. We just see the outer interface, but not the inner properties or the inner functionalities that helps to work the functionality. And it helps to reduce the complexity and helps in improving the code reusability. Once the class is defined already, we can use the class by inheriting multiple times. The real world examples is a car abstraction. Like you see a car and you start a car with the push button, but you don't know how it's internally it works. The internal mechanism is hidden. This is called as abstraction. Now you see, to write an abstract method, it's not a default feature. We use the abstract method. We have to import from the library abc and abstract method class from the library abc, that is called as abstract base class library. So from this abc we are going to import abc and abstract method. So this is called as abstract class. What is an abstract class? An abstract class consists of abstract like variables and methods. It's a common definition. Like a same class where it consists of methods and variables. You can also call them as attributes. So these methods are only instantiated whenever we call it through an inheritance. Like a parent class or a child class calls it parents class, then only these functions are executed. Those are like independent functions, like they don't consist of any method to be implemented. So these are also called as nullable classes or nullified classes. And then this abstract method, this is the syntax. So whatever you need to write the base class, and you can specify by using at the rate of, and then you can write it, and you can justly write pass. You need not to mention any of the implementation code in the abstract classes. Like these are not functioned, but you can get to know about them whenever your child class calls it from the parent class. So here is the example. So here is the class vehicle. This is the parent class, and here you are defining the abstract method called start, and this contains nothing functionality. So here we have declared pause. Now here we have two child classes, that is car and bike. So vehicle class child classes are car and bike. So here it consists of method start. So this car class can use the start method, and this bike class also can use the method start. So if we don't write an abstract method, like you need to define it, and this is only used here, whereas this is only used here. So what I am defining in the parent class, and I can use this start method in both of my individual classes. So here I am overwriting it because it doesn't contain any implementation in the parent class. Now in the child class I am writing for the car. I'm using car starts with a key or a push button, whereas in the bike, I'm using bike starts with a self start or click, whatever it may be. You just see a statement. It consists of statement. So now you know about how to create an object syntax. So you are creating a car and bike two objects. And if you call on car dot start, firstly it goes with an object car. What is the object of the car? It consists of what? A start method in it. So whenever you access car dot start off, then this method is instantiated, and then it gonna return the statement car starts with a key or push button. In the same way, whenever you go with a bike object, bike dot start executes the start function which is written in the class bike. So this is the start. So this part is executed here. This is how. So the final output would be car starts with a key button or a push button, and bike starts with a self start or key. So what's the use of this? You no need to write the same function multiple times, and you can use it from the parent class. And if you write here start, you can modify them according to your own child class. Here we that's why we use the abstraction. Now you see the polymorphism. Poly means many, like polymorphism, different types, like one interface, multiple implementation, like one code of block used to help in using like multiple interpretation, one interfaces and multiple implementation. Like the same function or method will behave differently depending upon the parameters. Like as you see in your previous in the function parameters, the same function, yes, with the different parameters. If you give two parameters, you see about the default argument and star argument, keyword arguments. With based on the parameters, the functional block would be different. Similar to this, based on the methods and attributes, the execution will be different. So if you see with a real world example as music player, the button and the play button and everything would be interface would be same, but once you press the play button, it starts the song. And in a video player, it's same play button used to play a video. Like by seeing it would be the same, but the functionality would be different. That is a simple example of polymorphism. So you can also call it as a dynamic typing or duck typing in Python. As you see in the previous parameters, like add, it may be a comma b, might be a integer, might be a float, or might be a string. Based on this, the output would be different. So if you see hello and world, two strings, then a plus b performs the concatenation. Whereas if the values are 3 comma 4 integer values, then it performs the mathematical addition, that is 3 plus 4 7. So in the same way, you can also see like these are the dynamic built-in function that not performs directly polymorphism, but they seems to be having a polymorphic behavior. If you see length of a string, it returns the number of characters in the string. Whereas if you see with the length of the list, then it tells the number of elements or the type of elements in the list. So add length, whatever the parameters. So this is called as Python's dynamic typing or duck typing. You can call it anyway. And if you see polymorphism in a general way, we will be having of two types. The one is method overriding, that is called as runtime polymorphism, and method overloading, that is called as compile time polymorphism. So we'll be seeing about it in later. So if you see a class animal and it consists of sound, so this self parameter, it's going to return some generic animal sound. Now we have classes, two subclasses, dog and cat, which are inheriting animal. So if you create dog dot sound off, then it would call bark. And if you see dog cat dot sound off, then it would print meow. So be the sound is the same function, but it performing different results. So this is called as runtime polymorphism. If you see with the method overloading, it has it doesn't support directly, but we can stimulate it like multiple methods with the same name but different parameters. As I told about add self a comma b comma c. If you add two parameters, it goes and prints a comma b and takes c as default. If you give three parameters, then it take a comma b comma c, and c will be assigned as 20. So this is how it is executed. Now if you move on, congratulations on mastering abstraction and polymorphism. Keep practicing, and then you will be getting a clear idea how to use these polymorphism and abstraction in detail. We'll be back with the next video again. Thank you for watching.